All right, so let's begin. So here's how you start graphing piecewise defined functions. All right, how many pieces do we have in this function right here? How many pieces to it?
Two.
Two.
Two. Yep. The first piece, let's write it out. The first piece is piece. Did I do that right? Piece is, write it all out, is f of x equals x. Let's do that first. All right. X if x is greater than or equal to 0. That's the first piece. And then later on, we're going to talk about the second piece, but not right now. We're going to do this part. All right. So we're going to do a little t table down here. X, f of x equals x. I'm going to be a little extra right now. I don't have to be. This is kind of simple. It's just x, but I'm going to do it anyway. All right. What numbers? Okay, let me first ask this. When we graph this piece, it's going to look like a what? See if y'all know this. Just this piece. It's just x. What type of function is that if it's just x?
Like a constant.
Not constant. If it was just a number, it would be constant, but it's a variable. So give me the general term for it. The broader term would be what?
Linear.
Linear. All right.
Oh,
Can
okay.
anyone tell me how I know it would be linear?
Because it's just a line.
But you don't. But we don't know that just yet. If you didn't know that it's supposed to be, give me a clue.
Because f of
In
x
this,
equals x.
I probably didn't teach y'all this. So let's listen up. This is how you know.
The
The
degree.
degree is 1. What do I mean about degree?
The
Can
X.
I
Exponent.
the highest exponent? So let me write this down. So the degree right here is 1 because it's x to the first power. So degree, write this down, is the highest exponent. If your degree is 1, then you're gonna have a piece of a line. All right. What numbers can we plug into this piece? It tells us we can only plug in x values that are greater than or equal to 0. It tells us, it gives us the criteria for it. All right. So I always want you, no matter what, to plug in these numbers first. And then you decide on what other numbers will work. But always plug in these numbers first. For this one, this first piece, I want you to plug in 0 first. All right. What other numbers will work?
1, 2,
Yeah.
3,
Yeah.
4.
And that's good enough because it's linear. Technically, for a linear function or a line, how many points technically do you need to draw a line?
Just two.
2.
Two, technically, two. We choose 3 normally to check the other 2. All right. It's not necessary, but it's a good way to confirm that the other 2 are correct. All right. If we plug in 0 into this piece, we get 0, don't we? So the
Mm.
point is 0, 0. We plug in 1, we get 1. Now that I look at it, is sort of like the identity function. F of 2 equals 2, 2, 2. All right. So we're going to go ahead and plot that on the graph. 0, 0 is right here on the graph. 1, 1 is here. 2, 2 is here. Here's what's crucial though. I'm not going to extend this line in both directions. Can I extend this line to the left? Can I go down this direction with this line? Or should I extend it to the right?
You gotta do it to the
You
right.
gotta go to the right.
Greater than or equal to.
Very good. Why can't I? So I got to go this direction like this. Why can't I extend it to the left for this piece, this first piece?
If you go to the left, it's gonna be less than 0.
Very good. The first piece says we only want this piece to cover the area where x is greater than or equal to 0. If we went this direction, now we're in negative x land. We don't want to go to the left for this piece. We only want to go to the right for this piece. Very good. All right, let's go to the, and notice I put my arrows. Make sure you put your arrows. It's going on forever to the right. Okay, now let's go to the second piece. The second piece is negative x if x is less than 0. Now I know this doesn't make sense to most people, but I know it doesn't say equal right here, but I still want you to plug in 0 first. All right. But we're going to make a note to say open circle there. Whatever we get is going to be an open circle. All right. So always, again, let me say this again, always start with these numbers when you are graphing piecewise defined functions. They're not always going to be closed based on the inequality. If it says equal, it's going to be closed. If it doesn't say equal, it's going to be open. All right. What other numbers can we plug in for this second piece right here? What numbers will work for x is less than 0?
-1 and -2.
Okay, -1 and -2. Yes, those are x values that are less than 0. All right, we're going to plug in 0. Again, what type of function is this? Negative x. Well, what's the shape of the, when we get finished, what is this going to look like? Negative x.
Linear.
Linear. How do you know again?
Because
The
of the
degree.
degree.
The degree
Yeah.
is 1. So that piece is going to be a line as well. All right. We just connecting two pieces together to make something else. All right. So f of 0 would be, it's still going to be 0, right? Negative 0 is neither negative or positive. All right. So that's just 0. So we got a point 0, 0. It's open, but it's already, if y'all notice, it's already filled in, so it doesn't matter. All right. And then f of -1 equals negative of -1. What is that? The negative of a -1. It's a
Would
positive
that be
1.
positive?
Positive 1. -1, 1. If you plug in a -2, then it's negative of a -2, which equals
+2.
positive 2. Then you get -2, 2. All right. We're going to plot this. 0, 0 again was open, an open circle. It doesn't matter. It was already, it's closed. It's like if you have a, if it's already filled in, you know, it really doesn't really matter. All right, -1, -1. We're going to go to the left 1, up 1. We're going to go to the left 2, up 2, so that you can see why this graph ends up being a V when you put it all together. All right, so that's where the shape is coming from. All right, any questions about, well, what's the domain of this function? Just asking, what's the domain?
Negative infinity, positive infinity.
Correct. What is the range? Somebody else. other than Kenneth?
Zero,
Rain.
zero,
Good.
positive infinity.
Infinity.
Very good. 0 to positive infinity. Is 0 included?
No, we put no. Yes.
Yes.
Yes, because it was the first piece. It did equal 0 in the first piece, so it covers the part that wasn't um, the part that was open. We only want to start at 0 because if you don't start at 0 for the second piece, then you're going to be missing 0.1111, right? Which, well, not 0.11, negative 0.11, which qualifies for that second piece. So you always want to start at 0, but put an open circle there. All right, here we go. Let's go to another one so we can get the hang of this graphing piecewise functions. We have two pieces again. The first piece is what? What is the first piece for this one?
X squared.
Yep, it's x squared. I'm going to write it as f of x equals x squared. Second piece is?
2x plus 1.
F of X equals 2X plus 1. Yeah.
Yep. All right, so first piece, again, let's do f of x equals x squared. All right, but this time is if x is less than or equal to 1. So what number do I want you all to start with on your table?
0.
0. Yeah.
Hmm? Huh? Huh? What
One.
number? 1. I want you to
Oh,
start
wait.
with whatever that number is right there. All right. I want you to start with this number. No matter what, I want you to start with it. All right. So we're going to start with 1. What other numbers will qualify x values that are less than or equal to 1? What else will qualify?
0.
0. Give me
Negative
something
1.
else. -1. Now, what's the shape of this first piece? It will be a piece of a what? The shape of the first piece. You may not know, but that's why what's the degree? What's the degree? Let me say that. What's the degree?
2.
2.
2.
2.
2 this time. It's
So would it
2.
be the shape of like a U or something?
Yes. So since the degree is 2, it's going to be a parabola. This is a quadratic function. All right, quadratic. It's going to be the P. It's not going to be a whole U because these are pieces of functions in a sense. So it's not going to be it's going to be a piece of a U. All right, so I'm going to at least plug in one more because if it's not a line, you need more information. You need more data. You need more points to figure out where is it curving. All right, let's plug in 1. We got 1 squared, which equals 1. So our first point will be what?
1.
1, 1.
1, 1. Plug in a 0. Yep, that's less than 1. So 0 squared, that would be 0. That would be 0, 0. Let's plug in -1. What's -1 squared?
1.
1.
1, and our point is
Negative 1. 1.
correct. And then we're going to plug in -2. -2 squared, which is
4.
4.
4. We have -2, 4. Now we could have kept going on to -3, -4, -5 if we wanted to. That's why you need an arrow on that side of things, okay? So let's attempt to plot this, keeping that in mind. So negative, well, first point, 1, 1. So where should I go to plot 1, 1?
To the
Go to the
right,
right 1.
1.
Up
Up
1.
1.
All right. 0, 0. That's my contribution right there. 0, 0. What about -1, 1?
Go to the left 1. Up 1.
Good. -2, 4.
Go to the left 2, up 4.
1, 2, 3, 4. Very nice. Now, which side is being extended? Am I going to draw the arrow on the left side, or I'm going to extend to the right?
It's going to be to the left.
Yep. So we're going in this direction to the left because this is when x values are less than 1. That's the domain of that first piece, x squared. Notice that I curved it because I knew that since it had degree 2, it should look like a U somehow. It should curve somewhere. Sometimes it may not even look like a U, but you should get a sense that is a U somehow. It curves. It's not a straight line. All right. Any questions about graphing that piece? Again, we don't want to go this direction here with this piece because we're only graphing when x is less than or equal to 1 for the first piece. All right. Let's go to the second piece now. Tell me what type of function is the second piece.
It's like a linear.
Yeah, it's the line. Yep, linear function. So f of x equals 2x plus 1. F of x and our point. All right. What number, I know it may not make sense to you right now, but what number do I want you to plug in first?
1.
1.
1. Thank you. But I also want you to put a little note saying what for this one, for 1.
Open
All
circle.
right. Open circle. Yes, we're going to put an open circle for this one. Whatever our information comes out to be, we're going to put open because it's really not, for this piece, not at 1. It's greater than 1. Give me some more numbers. Or greater than 1.
2.
2.
4.
4. 4. Okay, we can do that. Now, just saying, you could put decimals if you want. You could put 1.001, 1.2 to 1.3, but why do all that? You know it's going to look like a line, so as long as you have at least 2 points, you can connect those 2 lines. All right. So f of 1 equals 2 times 1 plus 1. Someone other than Kenneth and Alicia, tell me what is f of 1 equal to then if we plug in a 1?
3.
3.
Very nice. Very nice. All right. So our point is 1, 3. But that, make sure you know, just we gotta remember it's gonna be an open circle right there. All right. F of 2, 2 times 2 plus 1. All
5.
right. 5. Okay. All right. Someone other than Kenneth, Alicia, Ashley, and Christina, plug in 4 and tell me what you get.
It's 9.
9.
Oh, okay. 2 times 4 plus 1 is 9. So 4, 9. All right, great. So we're going to plot 1, 3. If I'm at the origin, where would I go to plot 1, 3?
To the right 1 of 3.
Yep. And keeping in mind, what can't we forget, though, for this one?
It's an open circle.
Very good. Open circle. Right here. All right. 2, 5. Where should we go?
Right 2 up 5.
Mm-hmm. And 4, 9.
Right 4 up 9.
All right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So In which direction are we extending this line? To the left, down to the left, or up to the right?
To the
Up to the
right.
right.
Up to the right. Okay. Like so. We're not gonna go in the other direction. Now if now here's what I want you to see. If this right here was bubbled in, what would that have violated?
The vertical line. Isn't that what it's
Ooh, okay. Who said that? Let me hold on. Let me go to the chat. Christina, did you say that?
I did.
All right, Christina. I see you. I see you. All right. So yes, if that was bubbled in, draw my line again. I erased everything. If that hole was bubbled in, it would have violated the vertical line test because if you draw a measuring line like so, it would have hit it twice. So if you see that happening, know that you did something wrong because this is a function. It should not violate the vertical line test. All right. It should not violate the vertical line. We already have a bubbled in right here. We can't have another bubbled in because it violates the vertical line test. And this can't cross over here. Again, we still violating the vertical line test. All right. Any questions? What do y'all think the domain is for this one?
Negative infinity to positive infinity.
Oh, nice. What about the range?
0 to positive infinity.
Very good. Very good. Kenneth, you know your domain and range. I see that. All right. All right. So let's go to one that has 3 pieces. See what happens. All right. So first piece. Someone other than Kenneth and Alicia and Christina tell me what's the first piece?
X
F of
plus
X.
4.
X plus 4. All right. Can someone tell me, other than them, tell me what shape or what type of function is the first piece?
Linear.
Yep. It'll
Sure.
just be a piece of a line. Yep. All right. And then I'm just going to write the other one. The second piece is f of x equals 4 minus x squared. If x is between 0 and 2, 0 not included though. All right. Third piece is negative x plus 4. All right. Then it says 2 less than x. That looks weird. Could we have written this in another way? Can you tell me another way that's written? So another way would be better if we wrote it.
X
X.
is
Yeah,
greater than
greater
2.
than 2.
Very nice. That's the same thing as x is greater than 2. So sometimes you may see things swapped around. So make sure if your homework, you just know that's the same thing as x is greater than 2. If you read it, if you put it from left to right instead of now it's from right to left. It's weird. Okay. The second piece, here's another question. Second piece, what is that shape going to be?
Quadratic
Part
function.
of a U.
Quadratic.
Yep. Yep. Quadratic is going to look like a piece of a
U.
U. Yeah, it's gonna curve a little somewhere. All right, so we just gotta keep that in mind. Let's graph the first piece now. All right, I may not be extra on these. I might just get to it. X, f of x. That's all I'm doing. Okay, for the first piece. All right, what numbers you want to plug in? It's just a line. What numbers you want to plug in?
-1
Yep.
and negative
Zero.
2.
I like 0. Y'all know I like plugging in 0. I can. So I'm gonna go ahead and put -1, 0, 1. All right, so this function is x plus 4. Uh-oh. I can't put in 1, can I?
No.
Nope.
No.
What can I plug in?
0.
-2.
-2. -2. Okay, I want to plug in -1, but we got to keep in mind this information, we got to look at the criteria over here on the right. This first piece only applies for x values that are less than or equal to 0. So we can plug in a -2. All right, if you plug in a -1 into f of x equals x plus 4, what would you get?
+3.
Very nice. If you plug in a 0, what would you get?
+4.
If you plug in a -2, what would you get?
+2.
Very good. All right. So again, all we're doing is evaluating the function, plugging in x values, and figuring out what the point is. All right. I'm going to go ahead and plot this. All right. So -1, 3. All right. Tell me where to go. So yeah, I want to make sure y'all know how to plot points.
Go to the left 1, up 3.
All right. Someone other than Kenneth and Alicia. All right. 0, 4.
Go up 4.
Go up 4. 1,
Yeah.
2, 3, 4. All right. What about -2, 2?
Go to the left 2 and up 2.
Left 2 and up 2. Okay. In which direction can I extend my line and put an arrow on it?
To the left.
To the
To the
left.
left. Very good. Because those are the x values that are less than 0. So these are the x values on this line right here that are less than or equal to 0. Good. All right, let's go to the second piece. F of x equals 4 minus x squared, but we got to remember though, we got criteria to look at. We can't just plug in anything we want. All right, it has to be between these two numbers, but what number you think I want to plug in first, no matter what, even though it may not make sense to you?
0.
0.
Yeah, I do want you to plug in 0 first. Give me something else that will work.
1.
1. Give me one more.
2.
Can we do 2?
Yeah, let's put in 2. We might have to put something else in because this is supposed to be a shape of a U, and I want to make sure it curves a little bit. Let's see. It might work out. If you plug in a 0 into this piece, what would you get?
4.
4.
4. Very nice. If you plug in a 1, 4 minus 1 squared, what would you get?
3.
3.
All right. If you plug in 2, so that'd be 4 minus 2 squared.
0.
0. All right. Let's see. 0, 4. Now on this one, I've got to put out a little note. There's an open circle at 0, 4. Why?
Because it'll mess up the vertical line test. Well, it won't be a vertical line.
Well, based on this little inequality here, why is it an open circle?
Because it's not a
Because
greater,
it's in
greater than or
between
equal to sign.
0.
Right, it's not an equal to sign over here on the left. It says really this is read as this is x is greater than 0. It's not an equal to 0, it's greater than 0. So that's why we put an open circle there to indicate that for this particular piece, it does not touch 0. But it's already filled in, so it really didn't matter, right? We're good. All right. So we're not doing anything, crossing over anything twice, like you said earlier. 1 3, 1 3. Where should I go? 1 3.
Right one up 3.
Right one up 3. Yep. And 2 0.
Right 2.
Right, two.
Okay. Now this is the piece that's supposed to look like a U. So is it looking like a U to y'all?
Not the
I
one you
was
used to.
We got a
not
small
the
curvature.
it's this one different. This U different. How? Can anybody tell me? This is a little different because it is. You may not see it. I may have to go ahead and tell you. It's upside down. It's flipped. Why is that? Because the leading coefficient is negative. See, in front of x squared is a negative. That's called a reflection. You're gonna learn that in the next section. All right. So when you have a negative leading coefficient, it flips over the x-axis. All right, we're gonna move on to the last piece of this graph, which is linear because it's still x to the first power. All right, but this time it's x is greater than 2. Okay, x is greater than 2. But what number? I know it doesn't make sense, but what number? It's gonna hit you why, but right now you may not understand why. But I just want you to do it anyway until it clicks. What number you think I want you to plug in?
2.
2.
2. Do and put a note saying it's gonna be open right there. Okay. All right. What other number will work? Other
3.
numbers.
Three,
3 and
four.
yeah. All right. So let's go ahead. I think somebody said something. You good? Okay. My internet said my connection not good. I'm not sure why. I'm at Lawson. All right, I'm on campus. All right, let's plug in a 2. Tell me what you get when you plug in 2 into this piece.
2,
Sure do, because negative 2 plus 4 is 2. What about 3?
1,
Yep. And 4?
0.
0. Yep. All right, we're gonna plot this. We'll plot 2, 2. Try to keep in mind that it's open. So 2, 2. Tell me where to go other than Kenneth and Alicia. 2, 2.
Right, three. Up one.
Oh,
Right
you
2 up 2.
yeah, you went to the second one. Okay, right 2 up 2. All right, open circle. 3, 1. I'm gonna go ahead and do it since you said it. 3, 1. And then 4, 0 will be here. In which direction should I extend my line? Up to the left or down to the right?
down to the right.
Down to the right, down to the right. Because it's greater than 2. So all the x values go in this direction. All right. Now, if this was bubbled in right here, if that was bubbled in right there, what would we have violated?
The
If
vertical
that
line.
open
Vertical
circle,
line.
yep, the vertical line test. If that open circle was closed, that's not right because that's not a function according to how you, if you graphed it that way. All right. It can only, for the function, it can only touch the vertical line once to be a function. All right, very good. We're going to go to our little word problem here. All right, it says wages. Wages. So I'm going to erase some of this. A mechanic's pay is $14 per hour for regular time and time and a half for overtime. The weekly wage function is W of H equals 14H, then H is between 0 and 40, then 21 times H minus 40 plus 560 when H is greater than 40, where H is the number of hours worked in a week. All right, first question. Why do you think they named this function W? Just ask them a simple question. That's all I want to know. Why do you think they?
For wages.
Wages.
Probably, yeah, probably for wages. All right, next question. What does the H stand for, you think?
The hours.
Number of hours.
Hours. Yep. Very good. Very good. Can anyone explain to me why we have 14H? What does that mean, you think? 14H.
14 hours.
No, $14 per hour.
$14 per hour. Very good. $14 per hour. When, what does this mean? We think that means $14 per hour when what happens?
When you work so many hours or less than 40 hours.
When you work,
40 hours or less.
40 hours or less. Very good. So you're on, for this, we're on the regular time. Okay, this piece is for the regular time, your regular work schedule. All right. Now, where is this, what is 21 coming from?
That's the time
14 times.
Time and a half.
Very nice. Can you explain what time and a half means?
So
Your regular.
is the regular time, and time and a half would be half 14, which is 7, right? So it's 21.
All right. So for overtime, when you work overtime, not only do you get the $14, you also get plus half of the $14. So 14 plus 7 is 21. Everybody gets that for overtime? I'm not sure everybody understand half time and a half, but that's what it means. Very good. All right, we got 21 down. We trying to understand this function. All right, and then what do you think H minus 40 means? What is that about?
The hours you work overtime minus 40.
Very good. So if we work over 40, then that would be our excess hours. That's why it's overtime. So this means that if you work 45 hours, then how many hours would be in excess? If you work 45 hours, how many hours would be in excess? How much would be over 5 hours? Very good. All right. Now they got a 560 right here. What is that about? 560. You think? Might have to break out a calculator. I don't know. 560.
That's the $14 per hour he makes times the 40 hours he works, right?
Very good. So this is given, right? If you're working overtime, you definitely gonna get 560 because that's $14 times 40. All right, that's the 560. $14 times 40. This part over here, in addition to your $560, you're gonna make that much money. Okay, very good. So if I say evaluate W of 30, what would you do? What does this mean? W of 30.
30 hours of work.
Plug in 30 where the H's are.
All right. Okay, W of 30. Yeah, 30 is in the place of H. So how do I evaluate this function at 30? What am I doing?
Multiply it by 14.
Very good. because we're going to plug it into the first piece. Why are we plugging it into the first piece only?
Because it's less than 40.
Yes, because it fits in this description right here. H is between 0 and less than equal to 40. All right, so 30 is in that interval or in that inequality. All right, so W of 30 equals 14 times 30, which equals what?
20.
What is it again?
420.
Thank you, 420. So I don't think I have the answers in front of me. All right, what about W of 40? You probably already know that, but do it anyway. What's
560.
W? 560. We kind of just explained it, didn't we? All right, 560. All right, what about W of 45? I'm giving you 2 minutes to work on that. W of 45. Do we plug that into the first piece or the second piece?
Go on the second piece.
And how do you know that?
This is
Because it's
over
working
Because
40.
it's
over
greater
40.
than 40.
Yep, is greater than this H is greater than 40. Our H for this one is 45. So we're going to plug into this piece. Very good. I'm going to give you like 2 minutes to work on it.
665.
Is it 665? Somebody else verify.
Yes.
All right, 45 minus 40 plus 560 is 665. Very nice. W of 50.
770.
770. All right, somebody verify. 77.
Yeah.
All
Yes.
right, very good. Now we're going to see if we can come up with a function based on this new information. What if the company increased the regular work week to 45 hours? What is the new weekly wage function? So we're going to change this function. We're going to call it H sub 1 or something. We're going to change the look of it based on this information. What would change?
0 is greater than H, greater than equal to 45. I think that's how you say that.
All right. All right. So definitely that part would change. Would the 14H, would that change? 14H for this one?
No.
Mm,
No.
no,
No, it's still $14 per hour. They didn't change that. They're changing the regular work week to 45 hours. Okay. That
the
sounds
the other
good. Okay.
the other one would be 21H minus 45
Okay.
plus uh what it'll be 665.
I think so. What y'all think?
Yes, it's
Yeah.
up
Yes.
there. The
Mm-hmm.
45.
It sound good.
Yeah.
14 times what? It should be 14 times what though? 14 times what? Not 14 times 40 this time.
45.
45.
45.
So what is
45.
14 times 45? I think she was close though.
630.
230.
630. 630. All right. Let's see. Six. Okay. Close header and footer. All right. 630. And on this side over here, on the right side, what would we put here?
H is greater than
H is greater
45.
than 45.
H is greater than 45. Good, good. So I think that's part of a homework assignment. Well, homework question. So just giving, I didn't do all of it, but that's part of it. I do want to cover one more homework problem before I let y'all go. All right, so let me find it on WebAssign. Mm-hmm. Okay. All right, this problem. The table shows the monthly revenue Y and thousands of dollars of a landscaping business for each month of the year 2016. So this is year 2016 with X equals 1 representing January. All right. First, let me ask you a few questions. What does Y represent?
Revenue.
Revenue. All right. Monthly revenue. And how much money? And what of what? And what type of uh, dollars? That's what I'm trying to say. Revenue on this table is in what? Of
Thousand.
what? In thousands of dollars. Okay, in thousands of dollars. Good. X equals to what again? What does this? Well, X equals 1. What does X equals 1 represent?
The month,
Which month?
January,
All right,
January,
so 2 would represent,
February,
so
February,
3 would represent,
March,
and so on. Very good. All right. So how much revenue was coming in January, you think? Say it in thousands of dollars. What do you think that would mean?
$5,100.
Very nice. So you could do 5 in your calculator, 5.1, if you don't know where he got that from. 5.1 times 1,000, and it will tell you $5,100. All right. So for example, what do you think about in May? How much revenue was coming in May, you think?
11,400.
Very nice. They're doing pretty good in May. All right. So just want to make sure you understand what this data is saying. All right. Next. Okay. I just want to first explain what is revenue. Can anyone tell me what revenue is? Because you all are my y'all all have the side hustles. What is revenue?
Money that you bringing in.
Money. Yeah.
All right. Well, what's profit then?
That's what you make from selling it.
But what's the difference? What's the difference?
Before
Revenue, I think
taxes.
it's throughout the year. I don't know.
Before taxes.
The money you
Oh, okay.
Yeah.
So revenue is everything that's coming in before you pay people. And if you said before taxes, before you pay the government, before you pay your employees, before you pay for the gas to put in the lawnmower. So that's revenue. Profit is when you pay all those people and it only comes back to you. All right. So profit equals revenue minus cost. That's an actual equation in business. Profit equals revenue minus cost. I just want to ask y'all that because y'all are my business owners and I need y'all to know the difference between revenue and profit. All right. So let me move on to the next section. This says a mathematical model that represents these data. So they took this information, this data up here, and they created a mathematical model from this data. So you can do that actually put in your graph calculator. It'll pop out an equation and everything. Notice that this equation is a blank defined function. What do I want you to say? This is called a blank defined function.
Piecewise.
Piecewise. It has 2 pieces. One piece is give me the shape of the first piece.
It's a line.
Line. And then the other piece is going to look like a piece of a quadratic. So based on that information, if you had to use a graphing utility, you could just use a graphing utility, but y'all know now which one of these 4 graphs could you have eliminated?
C and D.
The last two.
Right, these ones at the bottom, yeah. Whatever these are, they didn't put anything letters, but yeah, you're right. If this was C and this was D, we could eliminate those 2 because they're both straight lines. It has to be either this one or this one. Now, is this one because at 6, if you plug in 6, now, okay, let me ask you this. This piece is probably a what type of function right here?
Quadratic function.
Yep, quadratic. So would it correspond to the first piece of the function or the second piece of the function?
The
This one
second
up here,
piece.
the second piece.
Second.
So it's kind of backwards how it's on the graph, okay? So the second piece will correspond to this little piece of a U right here. All right. Now you could just plug in 6 to see where it lands. When you plug in 6 into this, it's probably going to land somewhere up here because even in this table, 6 is at 15.5. All right. Not here. This is below 15 right here. All right. So let me look at this one. Okay. This one is open circle. But yeah, this is the answer right here. Just to let y'all know. You can plug in 6 to see what it is. It is closed. It's telling you really that in, what is this, June, you're going to get this amount of money. So it won't be open. All right. You are receiving some money in June. All right. Next piece. What is the domain of each part? Look at the graph. This piece right here is from what x value to what x value? The first, this little line, this little U right here.
1 to 6.
1 to 6. All right. And for this straight line, is from what to what?
Look like
6 to 12.
6 to 12. But on this one at 6, it's going to be a what on the side of 6? What notation we're going to put?
A parenthesis.
Parentheses.
Parenthesis. All right. Very good. So I'm showing you the answers right now. For that line, it's going to be 6 to 12. It's going to be a parenthesis right here for 6 because it's open. It's open right here. But for the domain of that quadratic piece, it is closed everywhere from 1 to 6. So that's why it's going to be brackets right there. All right. Now look at B. Find F of 5. How do you find F of 5? Well, which piece does 5 correspond to? Is it between 6 and 12 or is it between 1 and 6? Which piece? The linear piece or the quadratic?
Quadratic.
Quadratic because 5 is between 1 and 6. The domain is 1 and 6. So plug 5 into this 0.519x squared minus 1.48x plus 6.1. You probably have different numbers because it's in red. Notice it's in red. That means you probably have a different number than I do. 11. F of 11. Where would you plug in 11? This linear piece or this quadratic piece?
Linear
The
piece.
linear.
The linear piece because 11 is between these x values, 6 and 12. All right. Interpret your results. The answer is these values represent the revenue in thousands of dollars. We already talked about that. It's not hundreds of dollars. It's thousands of dollars for the months of May and November. Where did they get May and November from? 5 is May and 11 represents November. So I just want to show you that for your homework that's due this week, okay? I gotta let you go. So I need to see the Adrian Moody. That's it. If you have questions though, I want you to stay behind and ask me those questions. All right?